Hello and welcome back to yet another tutorial in the Google Gemini series. I'm very excited to bring this session to you where I'm going to talk to you about agents. So what exactly are the agents? So in this session, I'm going to talk to you about what exactly are agents and how we build them and how they are related to function calling provided by LLMs like Gemini. And then we'll take a look at LangChain, which is providing us with the APIs and the SDK to build agents. So there are interesting demos and there are some interesting use cases that I'm going to cover in this session. So let's get started. All right. So what exactly are agents? Now, if you if you consider LLMs, they are extremely powerful. They have very good reasoning capabilities. And the best thing is the LLMs can tell you what they need to respond to the query that you sent. For example, if you ask an LLM, in order to respond to the current, in order to respond to a prompt that says, what is the current weather in Singapore? The LLM can come back to you and tell you that in order to tell you the current weather in Singapore, I need an access to an API or the actual weather embedded in the context. So embedding the actual content in the context is RAG, which we have seen in the previous tutorials. But what if we are able to provide a set of tools to the LLM and these LLMs will leverage the tools that are provided. Tools could be anything like searching on Wikipedia or searching Google or making a call to an API endpoint or talking to a database. So we provide a set of tools to the LLM and then we send a prompt and the agent will basically break down the prompt into a very detailed prompt and then sends it to the LLM to say, hey, in order to respond to this prompt, given that you have access to these tools, now break down the prompt and tell me how you want to use the combination of tools and the prompt to respond to this question. So agents essentially bring the power of LLMs and the capabilities of tools together to provide an appropriate response. So the best thing about agents is it leverages the LLM as the brain, as someone who is guiding through the process by breaking down the problem statement into multiple steps and figuring out which tool is best suited to respond to each of those steps, executing each of those steps and then consolidating the response and then coming back to the end user with an actual answer. So that's what our agents meant for. They are basically leveraging two things. One, a set of tools that we provide and a set of LLMs, sometimes more than one LLM, in order to accomplish a task. So this is very powerful, and the underlying phenomenon for agents is what is called as function calling. So in Gemini, there is a concept called function calling. So what happens is when we provide some existing a set of existing Python functions to Gemini, it can figure out how effectively it can call the function to accomplish a specific task. So typically a function has an input parameter and an output parameter. So Gemini function calling capability can take the prompt, can break it down, and based on the given functions and parameters, it can identify which is the ideal function to call. It automatically calls that function within your environment and uses that as a context and then comes back with the response. So I'm going to build a very interactive tool which is going to help us track flight status in real time. Now, as you know, LLMs, including Gemini, have a cutoff time. They cannot answer queries related to real-time prompts or questions. For example, you cannot ask, what is the stock of a company as on date? Or you cannot say, what is the status of the flight that just left a few hours ago? Or what is the status of an order that I placed yesterday? Now, in order to make the LLM respond to all of this, you need to provide the context. And context can be provided in one of the two mechanisms. One is, of course, implementing RAG, but RAG may not have up-to-date information. The other one is to provide or to empower the LLM with an API or a function where it can actually derive the context by invoking that endpoint or the function, and then using that to come back to you with the exact answer. So we'll actually take a look at both. First, I'm going to talk to you about how we can integrate functions with Gemini through function calling, and then how we can use LangChain and Gemini together to build sophisticated agents. So let's get to the demos. All right. So I want to set the stage by explaining you how we can link the current flight information with Gemini. So for that, we need to understand how we can actually find an API, or how we can use an API that will get us the status of the flight in real time. So I want to introduce an API to you from FlightAware. So FlightAware is basically a real-time flight tracking portal. Now, the best thing about FlightAware is they also give you API. So which means you can invoke this API by sending the flight number, and it comes back to you with the current status, whether the flight is scheduled or on the way, or it is delayed, and what is the estimated arrival time, and so on. Very interesting API, and it is fairly straightforward to invoke the API. All you got to do is get the API key, and then you don't even need to use a credit card. The basic user subscription will get you a key and you can use it. So you can use this API to build a flight tracking function. So that's the first step. Now, what I'm going to show you is how we can use the FlightAware API to get the status of a flight given the flight number. And then the second step is integrating that with Gemini. And the third step is integrating that with LangChain to build more sophisticated agents. So let's first understand how this API works. So I want to show you the invocation of this API. So we will retrieve the JSON payload coming out of the flight aware API. So we'll import the requests, and maybe it's a good idea to even import JSON, and then we will initialize the variables. So I'm actually getting the Aero API key from the environment variable. So I'm going to initialize these variables, and then I have written some helper functions. So the first helper function is to retrieve this session, and this session can be used every time you want to make a call. So we can avoid creating the session for each specific invocation. And then we also need a function that will actually invoke the flight data. So it takes the flight ID and the session that we created here, and it then takes the current time and the end date, which is typically the time delta between today and tomorrow. In cases where you are flying international, this actually makes sense. So I'm hardwiring this a little bit. And then we go ahead and set the API resource, and we invoke the endpoint and return the JSON. So that is the actual function. And then I also want this function to convert the UTC time to local time. For example, if I am asking for a flight that departs from San Francisco to Dubai, I want the departure time in PST, and I want the arrival time in the local Dubai time. So that's the reason why I wrote another function that says UTC to local. Now this function is basically responsible to convert the UTC time into the respective cities or the departure airport's local time zone. Perfect. Now after that, it's as simple as writing the function and invoking it. So now we actually write the function, which is get flight status. It takes the flight ID, and then it creates the API session. It creates the flight data, and then it it figures out whether the flight is estimated, scheduled, and then it retrieves the data and returns a long string that says the current status of flight from to is currently the status with the departure time and the arrival time. So we use this API to generate context for the LLM. So that's the function that I want to execute. Now let's go ahead and invoke this function. So first thing that I want to try is getting the flight status for one of my favorite flights, which is EK226, which is from San Francisco to Dubai. And now we get back this response from FlightAware's API that says the current status of flight EK226 from SF4 to Dubai is scheduled with the departure time as 4:45 local time and arrival time local Dubai time of 7:25. Now I can also invoke my connecting flight to Hyderabad, which is which is one of my other favorite flights, and this is EK524. Now this comes back and says, okay, here is EK524 flying from Dubai to Hyderabad. It is scheduled at 9:45 and arrives at 2:40 a.m. Hyderabad local time. Perfect. So now we have a function capable of feeding our LLM with the right context. Now we can feed this to the LLM as a tool and then make the LLM leverage it when we ask a question on what is the status. If we don't provide the tool, the LLM will hallucinate. It will give us some random ad hoc information that may not be real. But if we empower the LLM with the tool, which is nothing but a function, it is capable of using that to invoke the function and then use it as a context and then come back to us with the exact response. So now let's look at the second demo where we use this function that we have written as a tool for Gemini. So let's switch to the second demo. All right. So we start the second demo with exactly the same function. We start from where we left. So here is the flight function that we have written, exactly the same. Everything remains to be the same. We also have a new function called get departure gate. And to keep this simple, I have hard coded this to a gate number. So now what we'll do is we'll execute this and then I'll walk you through the steps involved in connecting this function with Gemini. So let's take a look at it. Let me bring this up and then populate each of the fields. Awesome. So I'm using the Google generative AI library. Make sure you grab the API key from Google AI Studio and set that up as the environment variable, which is Google API key. And once that is done, let's make sure we are able to invoke the function and the function works as expected. So let's type this. Perfect. So now this is working. The function is doing what it is expected to. And then we will now create the generative model object. And for that, we will pass the Gemini Pro as the model name, generation configuration as temperature 0. Now we need to set temperature to 0 because we don't want any hallucination or any creativity coming from the model. So we'll set that to temperature 0. And then we feed two tools, get flight status, which is this, and then get departure gate. We feed both these as tools to Gemini. What it basically tells the model is when the prompt is related to these tools and you have insufficient information to respond, turn that prompt into a function call, populate the parameters, call the function, use it as a context, and then respond to the user. You see, so much of heavy lifting is going into it. And the beauty of this SDK is it simplifies all of that by just giving us this list called tools. And as long as you populate it with the right functions, Gemini is capable of figuring out what to do at runtime. All right. So now when you look at the model, when we initialize model and look at this, it has the tools collection, the tools list, basically. So now what we'll do is we will start a chat session uh, with history enabled. And we also need to set this parameter, enable function calling is equal to true. Now, this is where the magic really happens. This is telling Gemini to leverage or use any of the tools that we mentioned here and automatically look up if there are any functions to call and automatically call them within the context, within the environment. So now let's invoke the LLM with this message that says, what is the status of EK226? Now, remember, we are not invoking the function directly. We are pointing Gemini to the function and we are sending a prompt. Now, if we don't provide the tools and enable automatic function calling, Gemini will tend to hallucinate, or it may come back and tell you, I don't know, I don't have information to real-time flight status. But because we have connected the dots between the function and the LLM, this is going to be a pretty interesting mechanism. Oh, okay, I need to execute this cell and then execute this. So now let's look at the response. That is going to be, okay, so let's print out response.txt when the execution finishes, and we should be able to see the output coming from the function. So now what is going on behind the scenes is Gemini is first figuring out that the prompt requires calling a tool. It looks at all the available tools. It finds that there is a tool called the get flight status. It then figures out the parameters required to call get flight status, and it is trying to make a call. So let's give it a few seconds and it should work. Sometimes function calling may fail because this is currently the SDK is in preview. So what I'll do, okay, there we go. So now it comes back. So the current status of flight EK226 from San Francisco to Dubai is scheduled with arrival time. Perfect. So now I'm going to again, repeat this with my other flight. This time, let me call 524, okay, and print the output. So this is going to invoke the function again, and it will come back with the actual response. Perfect. So now we have just enabled LLM to get the real-time status by connecting the tools. Now I want to introduce what is called as a React prompt. So what is a React prompt? React prompt tells the LLM to basically think step by step. So just like a human, when he receives a problem, he has to break down the problem into multiple steps and attacks each step independently and uses that to solve the remaining steps of the problem or the puzzle. Now, React, which stands for reasoning and action, teaches the LLM to follow a similar process. So here we are going to use a React prompt that will force the LLM to break down the problem into multiple steps and then apply reasoning to each of them and collect the thoughts and act on it. So first apply reasoning and then act. So to do that, we need to have a very detailed prompt. So React is a very sophisticated prompt engineering technique. It doesn't change anything. It is the way you talk to the LLM by giving it a step-by-step approach. So now we're actually creating a generalized prompt that says, use the tools provided to you to get the flight information. Always ensure accurate response. Think step by step. Now this is key. This is the key. And then you're saying, first find the status of first flight, find the status of second flight, find out the layover time by subtracting the arrival time from the first flight and departure time of the second flight, get the departure gate for the second flight. So you are essentially instructing the LLM precisely what you want. And this prompt will help us in basically forcing the LLM to think like a human. Now, if someone asks you, hey, I'm taking EK226 from San Francisco and arriving in Hyderabad by EK524, what is the layover time? What would you do? You'll first figure out the arrival time, then the departure time. You find the difference, and then you will look up a website or the information of the airlines, and then you come back with the exact gate. Now that's what we are telling the LLM to follow. So now we append this React prompt to the actual prompt. So now we have a prompt that looks like this. Okay, let's print it for clarity. So we have a very detailed prompt. Okay, so I'm arriving by, I'm departing by, how much time you have during the transit, and I'm giving a very detailed prompt. So this is called the React prompt. Now, what I'm going to do is I will simply send this prompt to the model and then print out the response. So what I want here is Gemini to tell me two things. One, what is the layover time in Dubai? And what is the departure gate? Now the departure gate, the funny thing is I have hardwired, but I could have used FlightAware's API, which actually does that to get the gate. But to keep this simple, I have hardwired. You can look up an API or a database or a streaming endpoint. It doesn't matter. But now we are basically expecting the LLM to invoke these two methods and come back to us with the response. Okay, occasionally you may see an error. That's fine. Let's go ahead and execute this. Now, remember this SDK is still in preview, so occasionally I see errors when I have React prompts, but that's fine. We can retry. And now hopefully it is executing and we should be able to see the response back. It is actually thinking. That's the reason why it takes slightly longer than a straightforward prompt. All right. Okay. So now we have seen the response. The layover time is 2 hours 15 minutes. That's very precise. If you actually look at the time, the arrival time in Dubai is 7:25. The departure time is 21:45. So it actually comes back and tells you it is 2 hours 15 minutes. And the departure gate for EK524 is B11. And B11 is our hardwired value. Now, this is the most powerful way of enabling LLMs with real-time data. And when you do this, you are getting a step close to creating agents, because agents use the LLM as a brain, use RAG as one of the contextual inputs, and tools, which are nothing but functions and APIs, as other mechanisms and outlets to get real-time information. So historical information comes from RAG, real-time information comes from tools. LLM acts as the reasoning engine and the brain, and the agent will use all of them effectively to respond to us with the exact answer. So we are very close to creating an agent, which is the next demo. Stay tuned. All right, so in this demo, we will extend the combination of functions and LLM to LangChain to build agents, of course, based on the React prompt. So let's explore the environment. First thing, we are retaining the same flight status function. Nothing changes there, except that we have imported additional modules related to LangChain and Google Vertex AI. So that is the first step. The most important thing that I want you to notice here is we have used annotations of Python to decorate this function as tool. So by providing this annotation, you are letting LangChain that this function is acting as a tool. It's very simple. You can take any function that you have written and add this annotation called @tool, and it instantly becomes available to LangChain for function calling. So that's a brilliant mechanism. So let's first execute all these cells. So we'll run all these cells. And once this is done, we will move to the next step. So, all right. So now the function calling is ready, we can go ahead uh, and basically execute the LangChain part of the agent step. So let's make sure we import everything that is required. And then we have a tool, right? So get flight status earlier is a tool. So to verify that this function is in fact a tool, we can access the details. For example, get flight status, name, description, and arts. So where is this coming from? Well, if you look at the documentation, this is very important. So instead of leaving this as a generic object, I am using the strict type checking, where I'm saying this must be a string. And then I have doc string that actually says returns flight information. Uh, and it returns a string. So LangChain basically figures out uh, all these from the doc string. So it actually finds the tool name as get flight status. The description is coming from the doc string, and the entire function is described as a JSON a schema. So flight ID is the parameter. The title is flight ID, type is string. So we have all the functions, all the parameters that are set. Now we will go ahead and populate the tools collection. So, just like we did that for Gemini, we are now populating the flight status. And then I'm going to create a prompt object from LangChain's prompt template. And this is actually a well-defined prompt based on the React mechanism. The previous demo showed you a React prompt very specific to flight information, flight status, the departure date, and so on. But this is very generic. You can use this prompt to basically have any kind of information without modifying the prompt. So if you look at the prompt, it has the actual React framework embedded inside this. So the input to the action is based on observation. The result of the action, thought, action input, observation can repeat multiple times. And I know the final answer, and you print the final answer. So basically you are instructing the LLM to analyze the information, that is reasoning, and then perform an observation, find out what else you want, and then do an action. So that is what the React prompt is all about. So now we will initialize the LLM, which is Gemini Pro, and then we will initialize the agent. So we will create a React agent, and we pass the LLM, which is Gemini Pro, tools, which is get flight status, and the prompt. Remember, LangChain is all about creating chains, and this is a chain for the agent. And once we have this, we will create an executor. So agent executor will basically connect all the dots, and we can readily invoke it. So now we are invoking the agent. What is the status of the flight? Always include the source and destination along with the timings. And I'm also enabling verbose is equal to true. So this is going to come back with an output. So we will print the output. But before that, let's go ahead and execute the agent. Because we have enabled verbose is equal to true, it shows, okay, so this is the executor chain, action, get flight status, action input is EK524. It derived that from the prompt, it invoked the tool, and it came back with the function output, which is embedded into the context. Now it finished the chain. Let's go ahead and print the output. Perfect. So now it comes back and says EK524 is from Dubai to Hyderabad, currently scheduled to depart, blah, blah, blah. This is perfect. This is very accurate. And this is how the agent functions. Now, I can actually make this slightly complex. The agent, LangChain agent, can leverage its built-in tools. For example, it can use math to figure out, how long it takes in the airport and how long it takes before I book a cab. So now I'm actually taking this to the next level. If I am arriving in Hyderabad by EK524 and it takes 1 hour to get the luggage, what time should I book the cab? Now, we are taking it to the next level, and this is where the agent comes in. Agent first figures out what time you're arriving, and then it applies its mathematical calculation abilities to find out 1 hour from the arrival time, what is the time, and then tells you when you got to book your cab. So let's go ahead and execute this. This is a very powerful mechanism. So we will now invoke the executor. Okay, so it is calculating. This may fail the first time because the API is currently not very reliable. So in case that happens, we'll execute it again. Okay, it finished the chain and it came back with the response 340. Now, what does this mean? Well, I actually said I'm arriving by EK524, which arrives at 240. Okay, and I said I may take 1 hour to get the luggage. So it figured out that the current time, the arrival time is 240 and it takes 1 hour. It calculates that and comes back with 340 as the ideal time to book the cab. This is just perfect. So this is the concept of an agent, where we are using tools that we are feeding into the agent, and some intrinsic tools like the mathematical calculations and the brains of the LLM to perform very complex step-by-step reasoning and performing actions based on that. So I hope you got an idea on how you can use functions, function calling, and agents with LangChain to perform some very sophisticated actions. So this brings us to the end of this session and also the entire series. I hope you found this useful. I'm going to link the articles related to these demos and tutorials, which I'm publishing at the news stack. So do look up the description. Whenever the article is ready, I'm going to update it. So I hope you found this useful. Don't forget to subscribe to my channel. I'm committed to bring you the latest and the greatest from the world of generative AI. Thanks for watching, and I'll see you soon with a new series.